This is the video recording for CLC Assignment 1 by Juan Espinoza
and Warren Peterson.
And one of the requirements of this assignment is that we demonstrate the process of resizing an array by including an explanation of array memory constraints. And we will do that. So one of the issues with regular arrays is that the size is fixed. So once we create the array, we give it a size, or we assign a size to it, and the memory that's allocated is fixed and cannot be changed. So for example, in our num list array below, we've got enough memory for 6 elements. We can't add any additional elements. We can't remove any elements, so no dynamic expanding or contracting this array. Array lists, on the other hand, overcome this fixed sizing limitation by allowing dynamic resizing of arrays. So essentially what an array list is, it's a class that allows for dynamic resizing of a traditional array. So if we take an original array, maybe we allocate memory to it, but it's empty. That's what's represented here in the original array. We add some elements. So some of it's occupied, but some of them are null values. Once the array becomes full,
then an ArrayList class has a method that identifies a built-in method which identifies if an array is full, and if the array is full, in our example, a new array is going to be created, one that is double the size of the original array. What we are going to do then is we're going to copy each of the elements in the original array over to the same location in the expanded array. So as we see here, that's what's happening. And then since we doubled the size, we have 5 elements that have null values. So once we copy this over,
we've got to get into some memory management, because we can't just have this hanging around and consuming memory when it's not being used. So instead of having it point to its own memory location like we do here for each one of these, we are going to point the original array over to the same memory location as the expanded array. So what that's going to do is eventually it's going to free up the memory that was previously allocated to the original array and make it available for use by other applications. And so that's a little bit of memory management that's built into the Java programming language, for example. So array lists also add for insertion of elements at any position in the object itself. So it can be in the beginning, it can be at the end, which we didn't illustrate here, but the beginning, middle, end doesn't matter. So as illustrated here, we've got our expanded array. We've added a 5 at the beginning, and then we threw a 45 and a 55 somewhere in the middle. So contracting the array would work similarly, but in reverse. So those are the key benefits of utilizing dynamic arrays or array lists over traditional arrays.
All right, so let's talk about the big data analysis. So big data is talking about the average case time complexity. When we're talking about the big O, big omega, that's talking about the worst case. But for this example, we're going to look at the average case. So each time we are doubling the elements in the array, we are 2xing the elements here. So if we go from 1 to 2 to 4, it's 2 in the elements. And the cost of insertion is 1, or 3 times the size plus 1. So the equation ends up being, for the time complexity of what we're doing here with the dynamic arrays, of O of n. This is because the number of operations grows linearly with the number of elements n. If n doubles, the number of operations double too. And that was our video. Thank you very much.